Okay, we'll start in 15 seconds. Huh? All right, ready to start. Good morning. Just our standard confirmation. If you are able to see the screen, somebody, Ali, Rafe.
Yes, sir. We can see.
Okay, great. Thank you. Thank you very much. So, quick recap of what we did last time. Last time we started on a new topic of Markov chains. Markov chains is a random process. It's a random process or stochastic process. एक ही बात है. Stochastic process, which is discrete valued or discrete alphabet, discrete valued. And these discrete values are encoded in states. And the process follows the Markov property. It satisfies the Markov property. Okay. So we have this random process xn. N is equal to 0, 1, 2, ... all the way up to infinity. And then xn can take one of the states, one of the discrete number of states. So states aapke paas, you cannot have a continuous value here because the number of states have to be countable. So you can take one of the discrete states with some probability. Okay. So these states are typically shown in a state diagram. We'll draw that in a second. And since this is a Markov property satisfying process, okay, so the probability that xm plus 1 is equal to state j is equal to j given xm is equal to I. So xm plus 1, this is future. Xm is equal to I, this is present. And if I give you more past, so ye given ke andar, if I am given additional information about the past, that xm minus 1 is equal to xm minus 1, xm minus 2 is equal to xm minus 2, and so on and so forth. X naught is equal to x naught. So all of this past information, all of this past information is useless for me for this future, because given the present, the future is independent of the past. So I can just write it as probability xm plus 1 is equal to j given xm is equal to y. अभी आपको मैं आज की स्टेट बता दूं तो आप कल की स्टेट वहीं से बता सकते हैं. You don't need to know what happened 10 years ago, 5 years ago, 1 month ago, 10 days ago, 1 day ago. आपको उसकी जरूरत ही नहीं है. All you need is the information today to tell me what it is going to be tomorrow. Okay? And this is true for all m. This is true for all m. This is true for all m. This probability that given you are in a state I today, what is the probability that you will be in a state j tomorrow? This is called Pij, or transition probability, or state transition probability. State transition probability. This is your state transition probability. And then we also designate the state transition matrix, or state transition diagram. State transition diagram. As an example, I will consider a Markov chain with two states, 1 and 2. And last time we said that it doesn't matter what those states are called. They could be, non-numeric states as well. But normally we use the numeral numbers to indicate the states. So you are in state 1, and you can move with probability 1 minus alpha to state 2, and 1 minus beta from state 2 to state 1. So what we are saying here is, okay, if you are in state 1, on the next transition instant, on the next time instant, the probability that you will stay in state 1, is alpha, and the probability that you will move out of state 1, जो next आपके पास जो भी transition instant होगा, जो counting करते जा रहे हैं day by day और second by second और year by year, but आपने ये times के ऊपर counting करते जानी है, and then you have this 1 minus alpha probability that you will transition from state 1 to state 2. Alpha is the probability that you will stay in state 1. And you can see that alpha and 1 minus alpha, they must add up to 1. So this is your probability state transition diagram. This is state transition diagram. Okay, or Markov chain state diagram. Different names used for that. The probability transition matrix corresponding to this state transition diagram is this. Okay, you are in state 1 and you move to state 1. So remember, हमने ये कहा था कि Pij means at one time you are in state I, you are moving from I to j. बस एक ही jump की आपको एक time jump आपको मिलेगा. So you move from state I to state j. So P11 is the probability that you were in state 1 and you stayed in state 1. P12 would be the probability you were in state 1 and you moved to state 2 on the immediate next instant. P21 similarly, and P22. Okay. Now, very important to realize, I'm not saying that okay, you are in state 1 now and sometimes in future you will be in state 2. We're not saying that. I'm saying that at the immediate next instant you move to state 2. P12 is given you are in state 1, you move to state 2 on the immediate, and this is very important, immediate next instant. Immediate next instant, जो भी next transition का time आएगा आपके पास. So the probability of this thing, given you are in state 1 and you move to state 2 on the next immediate instant, this is probability 1, 2. ये नहीं कह रहा है कि sometimes in future at n is equal to 7 पे आप 2 पे चले जाएंगे, नहीं. So and these probability transition matrix, these guys, the values here for this particular diagram is alpha and 1 minus alpha, and beta and 1 minus beta. Okay. This is your probability transition matrix, state transition matrix, probability transition matrix. Okay. Now we can also find what we call path probabilities. Path probabilities. Very simple. Path probabilities क्या चीज है? Path probabilities means कि probability x0 is equal to x0 and x1 is equal to x1 and x2 is equal to small x2 and so on. These x0, small x0, small x1, small x2, these are states. ये states हैं आपके पास 1, 2, 3, 4 कुछ भी होंगे. As we had said, these can be non-numeric, but we generally use numeric states here, and so on and so forth. Okay. Now I can apply the multiplication rule here. The multiplication rule says that this would be equal to multiplication rule. Apply multiplication rule. Multiplication rule क्या होता था? आपको रिमाइंड कराते हैं, A and B is equal to probability of A, probability of B given A. This was our multiplication rule, and for 3, 4, 5 आप सबके लिए कर सकते हैं. So if you apply the multiplication rule here, you are going to get probability x0 is equal to x0, right? Into the probability that x1 is equal to x1 given x0 is equal to x0. Okay. Into the probability that x2 is equal to x2 given x1 is equal to x1, and so on and so forth. So this guy here, probability x0 is equal to x0, this is the initial probability that when you started the chain, when you started the Markov chain, उस वक्त क्या probability थी? उस वक्त क्या probability? x0 is when you started the chain. What was the probability that your initial state was equal to small x0? What was that probability? ये आपको initial probability distribution से, probability mass function से पता चल जाएगा. ठीक है? What about these guys? This guy, probability x1 is equal to x1 given x0 is equal to x0. This is like one step time में आप एक step आगे गए हैं, x0 से आप x1 पे जा रहे हैं, and you have transitioned from x0 to x1. So this is really the probability transition, the transition probability Pij, या I से j के जाने के बजाय आप जा रहे हैं x0 से x1 में. इसी तरह P x1 x2 and so on and so forth. So this is the path probability. Generally starting point हमें जो है वो या तो दिया होता है या कहीं से हमें infer करना पड़ता है. This is the path probability. There is another probability that I can write here, which is probability x1 is equal to x1, x2 is equal to x2, and x3 is equal to x3, and so on and so forth until xi is equal to small xi, given you start with x0. Now see, this is the path probability, different from this probability. ये जरा इससे different है. ये आपको initial state दे दी गई है, and we are asking about these probabilities. Again इस पे multiplication rule लगाएंगे. So this will turn out to be equal to probability to start with x0 is equal to small x0. You move from small x0 state, एक time instant में आपने x1 के ऊपर चले जाना है. So this would be ट्रांजिशन प्रोबेबिलिटी x0 से x1 तक, फिर x1 पे आ गए तो वही मल्टीप्लीकेशन रूल, इंटू x1 से x2 इंटू x2 से x3 इंटू डॉट 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 xi minus 1 से xi. So this is your path probability, conditional path probability. Okay. So now I'm going to talk about state probability distribution. We talked about it last time as well, but very quick revision of this state probability distribution. देखें, हमने यहाँ पे कहा था कि probability x0 is equal to x0. What is that probability? When you started the Markov chain, तो हमें पता नहीं है कि कितनी probability है वो state 1 में है, कितनी probability है वो state 2 में है, ठीक है? So for defining this, let's consider a Markov chain. Consider a Markov chain. Consider a Markov chain xn where n is equal to 0, 1, 2. ये टाइम इंस्टेंट्स हैं, ये आपके पास टाइम इंस्टेंट्स हैं, 0 से 1, 1 से 2, 1, 2 से 3, ये टाइम आपका चेंज होता जाता है. एक मार्कov चेन है आपके पास xn जिसके पास कुछ स्टेट्स भी हैं, with states set और स्टेट स्पेस जो आपके पास है is 1, 2, 3, 4. ये states हैं आपके पास all the way up to r. By the way, these states can be infinite as long as they are discrete. You can count them. It is okay for them to be infinite as long as you can count them. Countable होनी चाहिए ये. Countably finite भी हो सकती हैं, countably infinite भी हो सकती हैं. So I define this PMF of x0, probability mass function of x0, that when you start the Markov chain, where do you start? Which state do you start from? Yeah. So PMF of x0, it is written as pi 0. Yeah. And this is equal to, this is a matrix or a vector if you like. This is a one row and many columns. So this tells you the probability that x0 takes some value. वो क्या वैल्यूज ले सकते हैं? x0 या स्टेट 1 में हो सकता है, या स्टेट 2 में हो सकता है, या स्टेट 3 में हो सकता है, या स्टेट r में हो सकता है. इसके अलावा और कोई पॉसिबिलिटी नहीं है. Okay? So x0 takes the value 1 or 2 or 3 or 4 with different probabilities. So this is probability x0 takes the value 1. x0 takes the value 2. Okay. So on and so forth. Probability x0 takes the value r. Okay. So this is really, ये जो आपके पास values हैं, this is the PMF. This is the PMF of x0. This is the PMF of x0. ठीक है, इसको इस तरह हमने ये वेक्टर की शक्ल में लिख दिया है, इसको हम बोलते हैं pi naught. This is pi to the power 0. Okay. So this is the PMF when you will start the Markov chain. So आपने एक Markov chain start कर दी randomly, हमें पता नहीं है कि किस state से start हुई है. It could be 1, it could be 2, it could be 3. You could have started with state R. किसी भी state से start कर सकते हैं. ठीक है. But once you started, now we know that you have started. Okay. Now it is pertinent to ask the question, what is the probability distribution or PMF of x1, x2, x7? इनके PMFs क्या होंगे? ये कैसे पता चलेंगे? Well, let's try to find out. The PMF of x1 is probability that x1 is in state J. x1 in state J, और J जो है वो 1 से लेके R तक कुछ भी हो सकता है. Okay. This is the probability distribution or PMF, if you like, probability distribution of x1, probability distribution of x1. Okay. Obviously, इसको J के ऊपर अगर सम अप करेंगे, सम अप करेंगे तो आपके पास आंसर जो है वो 1 आना चाहिए. Summed over all j probability x1 is equal to j, this should sum up to 1. And j should be going from 1 to r. जितने आपके पास स्टेट्स हैं उन सब के ऊपर करने. बट व्हाट आर दोज वैल्यूज? व्हाट आर दोज वैल्यूज? स्टार्ट का तो हमें पता चल गया कि ये वैल्यूज है. स्टार्ट का तो हमें पता चल गया कि ये वैल्यूज हैं, लेकिन एक टाइम के बाद क्या वैल्यूज होंगी? क्या चांस है? क्या चांस है कि आई विल बी स्टिल बी इन स्टेट 1? क्या चांस है दैट आई विल बी इन स्टेट 2? सो लेट्स ट्राई टू फाइंड दैट आउट. इसमें लेट्स अप्लाई द अवर हम बेसिक प्रिंसिपल ऑफ लॉ ऑफ टोटल प्रोबेबिलिटी. लॉ ऑफ टोटल प्रोबेबिलिटी जैसे हमने अभी ये मल्टीप्लिकेशन रूल इस्तेमाल किया. There is another simple way of finding this probability x1 is equal to j. Basic principle जो हमने बहुत शुरू में लर्न किया था वो क्या था? That was probability x1 is equal to j given x0 is equal to 1 into probability x0 is equal to 1 plus probability x1 is equal to j given x0 is equal to 2 into the probability x0 is equal to 2 and dot 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 plus the probability x1 is equal to j given x0 is equal to r. हमारे पास ये देखें r स्टेट्स थी, सिर्फ जो स्टेट स्पेस है उसमें 1 से लेके r तक है. So x naught could have taken any of these values into the probability x naught takes the value r. So this can be written as summation upon k probability x1 is equal to j given x naught is equal to k into the probability that x naught is equal to k. Okay. Now, what is this guy? What is this guy? x1 is equal to j given x naught is equal to k. This is the transition probability going from k to j, in one step. ये देखें x0 से x1 पे एक ही स्टेप में नेक्स्ट इंस्टेंट पे हम k से j पे चले जाएंगे. एक से ज्यादा अगर होंगे तो वहां पे ये चीज वैलिड नहीं होगी. सो वेरी वेरी इंपॉर्टेंट टू रियलाइज कि ये सिर्फ एक ही का स्टेप होना चाहिए. या x5 से x6 पे चले जाएं या x20 से 21 पे चले जाएं. यहाँ पे x0 से x1 पे जा रहा है. सो x0 से x1 पे जाते हुए यू आर मूविंग फ्रॉम स्टेट k टू स्टेट j. सो दिस शुड बी इक्वल टू pkj, of course summation over all k into the probability x naught is equal to k. X naught is equal to k. And what is this probability x naught is equal to k? ये तो भी हमने लिखी है यहाँ पे. Probability x naught is equal to k is one of these guys here. ये जो हमने ये pi 0 लिखा है, इसके अंदर से x naught is equal to k हमने कोई उठाना है. ठीक है. And obviously k is going from 1 2 3 4 all the way up to r. So k is going from 1 to r. Okay. So this is the PMF of x naught, which we already know. हमें starting distribution का पता है. Starting distribution का पता हो तो मैं next time के ऊपर distribution मेरे पास आ जाएगी. And since this is Markov, अब मेरे पास x1 की distribution आ जाए तो मेरे पास x2 की distribution आ जाएगी. x2 की distribution आ जाए तो x3 की distribution आ जाएगी. And so on and so forth. Yeah. So now, if you look at this guy here, probability x naught is equal to k. देखिए इसको हमने sum up करना है. I can probably write it as this is your pi 0, which is probability x naught is equal to 1 dot 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 probability x naught is equal to k dot 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 probability x naught is equal to r. ये आपके पास r elements हैं इसके, which is the starting probability mass function or probability distribution of x naught. x naught की probability distribution है, Markov chain की starting distribution है, in which state you are in with what probability. So if you think about it, I am going to write this matrix here. This matrix is P11 P12, which is your probability transition matrix P. Dot 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 P1 R. Similarly, P21, P22, and P2R. P31, 32, dot 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 PR1. Okay, and then you have PR2, so on, PRR. ये इस तरह से आपकी probability transition matrix है. ठीक है. If you think about it, कि what is this number here? This guy, probability x equal to j. इसकी right side को देखें. यहाँ पे क्या हो रहा है कि probability x naught is equal to k for k going from 1 to r. For k going from 1 to r. इसका मतलब है कि मैंने इसको यहां से लिया, इसको मल्टीप्लाई करना है. देखें k को अब आइटरेट करें from 1 to r. So this guy and then this guy and then this guy and this guy and this guy, they get multiplied with pkj. Okay, and then pkj का मतलब है अगर j is 2, if j is 2, then I'm talking about this column here. If j is 1, then I'm talking about the first column here. So ये देखें, ये सारी चीजें multiply हो रही हैं इनके साथ, and I'm going to just write that here. So ये पहला वाला एलिमेंट इसके पहले एलिमेंट के साथ मल्टीप्लाई हो रहा है. Think about it. k को आप 1 लें, so you have P12, j is 2, P12 multiplied by this guy. Okay, and then this guy, kth guy multiplied with kth guy, and the rth guy multiplied with the rth guy. So what is happening here? Okay, this guy gets multiplied with this guy, the second guy gets multiplied with the second guy, the last guy gets multiplied with the last guy, and they are added together, So this is simply a multiplication of this vector with this matrix, and this vector has a dimension of 1 is to r, and this matrix has a dimension of r is to r. So the resulting will have a dimension of 1 is to r. Okay? And that 1 is to r would be the distribution of x1. Okay. So what I can write here is that pi1 is equal to pi0 times p. Pi1 is equal to pi0 times p, and pi1 is the distribution of x1 in a vector form. Pi0 was the distribution of x0 in the vector form. ये थी हमारे पास pi0. This was our pi0. Probability x0 takes value 1, x0 takes value 2, x0 takes value r. And this pi1 is probability x1 takes the value 1, x1 takes the value 2, x1 takes the value 3, and so on and so forth. Okay. Similarly, I can write pi of 2 is equal to pi of 1 times p. क्यों? क्योंकि मार्कोव है. जब आप स्टेट 1 आपको पता चल गया n is equal to 1 के ऊपर आप किस स्टेट में है, then you are at the same position जहां पे आपने स्क्रैच से स्टार्ट की. एक दफा p से मल्टीप्लाई करेंगे तो you will move to the next time instant. Okay, so similarly pi 3 is going to be equal to pi 2 times p, and dot 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 pi n would be equal to pi n minus 1 times p, and then pi n minus 1 times p can be written as pi n minus 2 times p into p. Okay. So dot dot dot, this would become equal to pi of 0 times p power n. So this is your pi of n. Now, what is pi of n? This is distribution of xn. And what is y0? This is probability distribution of x0. And P is your probability transition matrix. तो एक दफा मल्टीप्लाई करेंगे तो you move one step. दो दफा करेंगे तो you move two steps. Okay. So that means I can go with this example, which has a probability transition matrix of 1/2, 1/2, and then 2/3, 1/3. Okay. I can draw the state diagram here. The state diagram is you have state 1, you have state 2, okay. And from state 1, you come back to the same state with 1/2, move to the next state with 1/2. ये आपके पास है. From state 2, you come back to the state 1 with probability 2/3 and stay back in the same state with probability 1/3. Okay. So given x0 is equal to 1, that is, your Markov chain started in state 1. If it is given that your Markov chain started in state 1, find the probability it's in state 1 at n is equal to 3. 3 times के बाद भी वो उधर ही होगी. 3 times के बाद भी वो उधर ही होगी. तो कैसे करेंगे? So we know कि pi 0 in this case is equal to 1, 0. You started with state 1, तो उसकी probability को 1 कर दिया. And then I'm interested in pi 3, which is equal to 1, 0 into this 1/2, 1/2, 2/3, 1/3 power 3, which turns out to be, इस matrix को multiply करेंगे 3 बार, 29/72 and then 43/72. Okay. So that means कि probability that Markov chain is in state 1 at n is equal to 3 is 29/72. Okay. What is the probability Markov chain is in state 2 at n is equal to 3? This would be equal to 43/72. लेकिन दोनों add up होकर 1 भी होंगे. Okay. Now, last time we talked about limiting distribution. ये आप अगर इसको मल्टीप्लाई करते जाएंगे 3 के बजाय 4, 5, 6, 7, 8, 9 इनफाइनाइट टाइम्स आप मार्कov चेन को रहने दें वहां पे, just leave it alone for a very, very long period of time. What would be the probability you will see the Markov chain in state 1? And what would be the probability you will see the Markov chain in state 2? Now, if you look at the state transition diagram here, इससे मुझे ये लगता है कि if you are in state 1, there is 50-50 chance you will stay in state 1 or go in state 2. If you are in state 2, there is more chance that you will go in state 1 and less chance that you will go in state 2. Okay, more chance that you will go in state 1 and less chance that you will stay in state 2. So that means in the steady state, if I leave this Markov chain alone for a very long period of time, then I'm asking that at n is equal to infinity, what is the probability that you are in state 1? What is the probability that you are in state 2? Which answer will be greater, state 1 or state 2? Chance to be in state 1 greater or smaller? Chance to be in state 1 greater or smaller? Answer in the chat window. Answer in the chat window. Greater. There is more chance that you will end up in state 1. This is after an infinite period of time. Okay. कैसे मालूम करेंगे कि what is that probability? What is that probability that I will find the Markov chain in state 1 at n is equal to infinity. How do I find that probability? Last time we talked about this and we said that it is defined by the stationary distribution. It is defined by the stationary distribution. And the stationary distribution is this alpha 1 minus alpha. ये एक आपकी stationary distribution है. And this multiplied with your probability transition matrix 2 by 3, 1 by 3, this should equal to alpha 1 minus alpha. So this is two simultaneous equations. You solve them and find out alpha. You solve these two simultaneous equations and you can find out alpha. Find alpha. And that value of alpha will tell you that if you start in a probability distribution alpha 1 minus alpha, you will get the same distribution. So that means कि steady state में जाके ये convergence आ जाएगी. And this is our limiting distribution as well. Limiting distribution. Okay. Or stationary distribution. Stationary distribution का क्या मतलब है कि if you start in the stationary distribution, so you will remain in the stationary distribution. अगले टाइम पे भी stationary में रहेंगे, उससे अगले पे भी stationary में रहेंगे. Limiting distribution का क्या मतलब है? Limiting distribution का मतलब ये है कि if you start in any distribution, ये देखिए हमने 1 0 से start कर दी थी, ठीक है? If you start in any distribution, you will end up at n is equal to infinity. You will end up in the stationary distribution. Okay. So definition क्या होगी? यहाँ पे हमारे पास stationary distribution की start in this, will stay in this. ये इसकी definition है. Okay. And limiting distribution क्या होगी? Limiting distribution की क्या definition होगी? Start in any distribution, will end up, and when I say end up means n going to infinity, very large n, okay, will end up in limiting distribution. And it's no surprise that limiting distribution is the same as the stationary distribution. Limiting distribution आपकी stationary distribution ही बन जाती है, क्योंकि n is equal to infinity पे जाके जहाँ पे आप stable हो जाते हैं, ठीक है, then you input that distribution और उससे अगले टाइम के ऊपर infinity plus 1 टाइम के ऊपर भी आपके पास same ही distribution है. That's how you had achieved convergence. ठीक है? So there was another way of finding the stationary distribution by taking the transpose of this probability transition matrix and finding the eigenvector of that probability transition matrix corresponding to an eigenvalue of 1. That was another way of finding the stationary distribution. Okay. So great. I'm not going to talk about, although we have discussed it implicitly, I'm going to talk about what we call n-step transitions, n-step transition probabilities. N-step transition probabilities. Normally, we only talk about the transition probabilities. Okay, Pij is the probability you go from state I. Let me just explicitly write it, from state I to state J in 1 unit time, Okay, in 1 unit time. इसको कभी कभी ऐसे भी लिख देते हैं, also written as Pij, ऊपर यहाँ 1 लिख देते हैं. इसका ही मतलब होता है कि ये 1 यूनिट टाइम में, ना भी लिखें तो उसका मतलब है कि 1 यूनिट टाइम में. That means that I should be able to write Pij2, which is the probability that x2 is equal to j, I से आप j में जा रहे हैं, starting with x0 is equal to I. तो ये देखें दो टाइम स्टेप्स के अंदर, okay, you transition from I to j in 2 time steps. Okay? Transition from I to j in 2 time steps. In 2 time steps. Okay? Of course, this should be the same as probability x7 is equal to j given x5 is equal to I. x5 is equal to I. Yeah. लेकिन यहाँ पे भी दो का डिफरेंस है, यहाँ पे भी दो का डिफरेंस है. If the probability transition matrix does not change, if the probability transition matrix, if P does not change with time, time के साथ change ना हो, जो normally is the case, normally is the case. Now, Markov chain will be stationary. Markov chain, a Markov chain is stationary. Stationary Markov chain की दो properties थी. One, P does not change. P does not change. P does not change with time. P fixed रहता है. The other requirement was you start in not just any distribution, in stationary distribution. In stationary distribution. उसमें start करेंगे और उसी के अंदर रहेंगे आप. क्योंकि stationary distribution है, you will remain in the stationary distribution. Okay. Last time we gave you an example. We gave you an example of a periodic Markov chain. एक periodic Markov chain की आपको example दी थी, जिसके केस में limiting distribution exist ही नहीं करती थी, convergence ही नहीं आती थी. You will always flip flop between one state and the other state. एक state और दूसरी state के बीच में flip flop करते रहते हैं. एक और दूसरी state के बीच में flip flop करते रहते हैं. And I have that example from last time. जो हमने काउंटर एग्जांपल आपको दी थी कि sometimes limiting distribution does not exist. Okay. Stationary distribution may still exist, and the example that we provided for this last time was this guy. 1, 2 states, and they are just moving with probability 1. So ये एक बड़ी boring किस्म की Markov chain है, जो 1 से 2 में चली गई, 2 से 1 में आ गई, with 100% probability, with 100% probability, and this is a periodic. This is an example of a periodic Markov chain. Periodic Markov chain. क्यों periodic है? कि 1 को देखें, एक पीरियड के बाद वो विजिट होता है 1. वो पीरियड क्या है? वो पीरियड है 2. वो पीरियड है 2 जिसके बाद वो लाजमी विजिट होता है. So this kind of a Markov chain has a probability transition matrix which is given by 1 से 2 में जाने की probability 1 है, और ये इस तरह की इसकी probability transition matrix. And we note that कि if you start with 1/2, उसको आप 0, 1, 1, 0 से multiply करें, you will end up getting 1/2. So this guy 1/2 is your stationary distribution. Is your stationary distribution. Okay. This P or this Markov chain, it doesn't have a limiting distribution. इसका क्या मतलब है? इसका मतलब ये है कि स्टार्ट करें किसी भी चीज में, not the stationary distribution, किसी और डिस्ट्रीब्यूशन में स्टार्ट करें, आप कभी भी जो है स्टेशनरी तक नहीं पहुंचेंगे. Okay? That means start in any distribution other than the stationary distribution, other than the stationary distribution, and you will never ever reach stationary distribution. कभी stationary distribution तक पहुंच ही नहीं पाएंगे. This was the example that we provided last time. Then we can use some tricks to solve the state transition diagrams, or the finding the probabilities of stationary distribution. So I will give you one more example maybe here, but before that I have to finish this and state transition topic. So we talked about this Pij2 as the probability xj is equal to j, x2 is equal to j given x naught is equal to I. So दो steps के अंदर आपने I से j पे transition करनी है. ठीक है? So I'm going to write it here again. This was a side note. This was a side note. तो वापस आते हैं यहाँ से. Back to and state and step transition. Probabilities. So we are interested in Pij 2 steps में. ठीक है? So that means probability x2 is equal to j given x0 is equal to I, or x7 is equal to j given x5 is equal to I. Same thing. वहां से स्टेशनरी से उसकी डिस्कशन में आ गया. Now what I can do here is your Markov chain at n is equal to 0, at n is equal to 1, at n is equal to 2. I am interested in the following. I am interested in कि मेरे पास जो ये states हैं 1 से लेके r तक, it is given to me that I am in state x0 is equal to I. I am in ith state. I am in ith state here. So ये आपके पास जो है ये state space है. This is state space. Okay. 1, 2, 3, I to R. ठीक है? So what I am saying here is कि इनमें से ये सारी possibilities हैं. इसी तरह यहाँ पे भी 1, 2, ... I, j, k all the way up to R, or n2 is also 1, 2, ... j कहीं बीच में आएगा R. ये आपके पास R states. So you have a Markov chain with 1 to R states. Okay, and the time is progressing here. Okay, we are given that x naught is equal to I, which means that we are starting with this guy, and we need x2 is equal to j. Okay. Now we don't jump from one state to another state in 2 time instants. हम तो हर time instant के ऊपर jump कर रहे होते हैं. ठीक है? So what is possible here is that you are going from 1 to R and then R to J. You could also be going I to 1 and 1 to J. You could also be going I to 2 and 2 to J. You could also be going, ये 2 steps हैं आपके पास. तो मुझे नहीं पता पहले step में क्या होगा, मुझे ये भी नहीं पता दूसरे step में क्या होगा. What I am interested in is कि पहले step से पहले मेरे पास x0 जो था वो I था, ये मुझे पता है, और x2 जो है वो J था, These 2 guys are interesting. What happens at n is equal to 1? I don't care what happens at n is equal to 1. ये कुछ भी हो सकता है. So let's try to write this probability that x2 is equal to j given x naught is equal to I. x2 is equal to j given x naught is equal to I. So this is Pij2. This is equal to sum of all of these paths, probabilities of these paths. This is again from the law of total probability. Okay, so this would be equal to summation k is equal to 1 to r, k is equal to 1 to r, pik into pkr. So the probability that you go from n is equal to 0 to n is equal to 1. So pi1, pi1, this is pi2, this is pik, this is pir, and this is prj, this is p1j, p2j, and इसी तरह pkj, pkj. So this would be equal to pkj, pkj. ठीक है. So I से तक j तक जाने के लिए दो टाइम इंस्टेंट्स हैं, दरमियान में कुछ होता है, हमें पता नहीं है क्या होता है. There are many different possibilities. So think about it कि you are going from Lahore to Islamabad, ठीक है, and you have multiple paths to take. You have multiple paths to take. So the probability that you start with a specific point in Lahore and end up at a specific point in Islamabad, add up all the probabilities, all the possibilities of all the various different paths which are available to you, and then this is from the law of total probability. This is from the law of total probability. Okay. But we also know that in two steps, when you transition, then what you have is P2 is equal to P112, P122, dot 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 P1R2. ये आपने दो स्टेप्स की ट्रांजिशन है. So these are not transition probabilities, not the standard transition probabilities. So this is two-step transition probabilities. P22. So दो steps करें और आप उधर ही आ गए. And PR1, 2, PR2, 2, and this is PRR2. Okay. Each of these elements, this guy here, okay, ये कैसे हम find out करेंगे? ये find out करने के लिए we have to use this kind of a formula. And this formula is nothing but the multiplication of those two matrices. This is equal to P11, P12, P1R, P21, PR1, dot dot dot, PRR, multiplied by the same guy, P11, P12, P1R, P21, PR1, dot dot dot, PRR. Yeah. And you can see कि इसमें से PIK into PKJ, is the probability you are going from ith row to jth column. So इसकी हम ith row को पकड़ लेंगे और यहाँ से हम jth column को पकड़ लेंगे, and those multiplied together is this guy here. So P2 is really equal to P squared. So this was for a two-step. Probability transition. What about if you have to transition? If you have to transition many steps, not just two steps? Pij m plus n steps. Pij m plus n. Okay. So this is very simple. यूं समझ लें आप कि you start with I and you end up with J, and in the middle you have many of these steps. So you go here and then you come here. So ये 1 से लेके आपके पास R तक दरमियान में कहीं K भी आएगा. So you go here and then you go here. You go here and then you go here. So this is, these guys are m steps. Okay. And here you have n steps. That means if you have x not here, then you will have x m here and x m plus n here. Okay. इनके दरमियान डिफरेंस जो है वो m का होगा, m स्टेप्स है, इनके दरमियान जो डिफरेंस है वो n का होगा, n स्टेप्स है आपके पास. So that means I can write p I j m plus n is equal to summation k is equal to 1 to r. Okay. p I k, I से k तक चले जाएं आप m बारियों में, and then p k j, k से j तक चले जाएं in the next n time steps. In the next n time steps. By the way, this would really be equal to k is equal to 1 to r p I k m minus 1 and p k j n plus 1. क्योंकि दोनों का सम फिर भी जो है वो फिर भी आपके पास m plus n आ जाता है. तो m minus 1 steps पहले कर दें और n plus 1 step बाद में कर दें, या m steps पहले कर दें और n plus बाद में कर दें. This expression here, this is called Chapman-Kolmogorov, a Russian mathematician, equation. Chapman-Kolmogorov equation. So let's do some example of these, n-step transitions. So first of all, let's say consider this. So let's say in applied probability course, every week we have a quiz and a homework. So every week you are either up to date. We can see that 5 people are watching this lecture today, right now, and 115 students are not watching it. They will probably watch it today, I hope, and they will become up to date. हो सकता है कि वो 2 हफ्ते तक भी लेक्चर ना देखें, 2 हफ्ते तक भी लेक्चर ना देखें. So they will lag behind every week. So there are two states, and every week the state will change. So the first state is you are state 1, you are up to date with the lectures, and the state 2 is that you are lagging behind. Okay. I can model this as a Markov chain. If you are up to date in 1 week, then there is a high chance that you will remain up to date in the next week. And if you are up to date today, there is a small probability that you will be lagging the next week. जो अभी तक सही चलता आ रहा है, आगे भी hopefully सही चलता रहेगा, but there is a small probability, 20% chance that you will lag behind, but probably you will cover up in the next week. Similarly, if you are lagging behind, then you try to make an effort, and with some probability, not as high as 0.8, but 60% chance that you will try to catch up, and you will go to up-to-date state. And there is a 40% chance that you will still keep on lagging behind. Okay. Now, if we look at the n-step transition probability, कि 3 weeks के बाद क्या होने वाला है, आज अगर लैग कर रहे हैं तो 3 week के बाद क्या होने वाला है. So if you are lagging today, will you be lagging 3 weeks from today or not? I can answer all sorts of those questions. What is the probability transition matrix? P is you stay in state 1, you move to state 2. You stay in state 2, you stay in state 2 or move to state 1. So this is your probability transition matrix. Yeah. Probability transition matrix. What is going to happen after 1 week? Okay. What is going to happen after 1 week? Okay. So after 1 week. So if I tell you what the state is today, this probability transition matrix will tell you what is going to be the probability distribution next week. Okay. If I tell you what is the probability distribution today, 1 or 2 state में होने की क्या probabilities हैं, I can ask you, okay, what is going to happen in 2 weeks? You cannot answer that directly. You have to first go for 1 week and then go for another week. Okay. So P square in this case is going to be 0.8, 0.6, 0.2, 0.4 times 0.8, 0.2, 0.6, 0.4, which turns out to be equal to 0.76, 0.72, 0.24, 0.28, 0.24, 0.28. So this is your P square, also P2. Okay. So the elements of P2, which are P11 in 2, P21 in 2 steps, P12 in 2 steps, and P22 in 2 steps. By the way, these guys here, this is P11 in 1 step, जिसको खाली P11 भी लिख देते हैं, ठीक है? And this is P22, can also be written as P22 in 1 step. 1 step तो by default होता है, 1 step तो by default होता है. But 2 steps में क्या हो रहा होता है? So this P112 is 0.76. So you started with certain distribution. You can find out 2 steps later what the distribution is going to be. Okay. So I'm going to write the progression of this matrix, 0.8, 0.6, 0.2, 0.4. This is for n is equal to 1. एक दफा की एक स्टेप के लिए मुझे ये मैट्रिक्स चाहिए, दो ट्रांजिशनों के लिए मेरे पास मैट्रिक्स है 0.76, 0.24, 0.72, 0.28. तीन दफा के लिए एक दफा फिर उसको p से मल्टीप्लाई करते हैं, so you will get 0.752, 0.744, 0.248, and 0.256, and so on and so forth. N is equal to 2, n is equal to 3, n is equal to 4 के लिए मालूम करें, n is equal to 5 के लिए, n is equal to 5 के लिए you will have 0.7501, 0.7498, 0.25, 0.25. ये कन्वर्ज हो जाती है. So if you have n is equal to infinity, then you will end up getting 0.75, 0.75, 0.25, 0.25. Okay. What that means is that this 0.75, 0.25 is the stationary distribution. You will end up with this guy. In state 1. If you leave the semester running for many weeks, 15 weeks में हो ही जाएगा, 14 weeks में हो ही जाएगा. So 75% chance that you will be up to date. So not a very bad situation. 75% chance that you will be up to date, which means that roughly 75% of the students will be up to date. So with n, you can plot all of these probabilities. So ये आपके पास 0.8 से start होती है, फिर 0.76 हो जाती है, 752. So you can plot these probabilities. So I'm going to plot n here, and we have 0.75 here and maybe 0.25 here, 0.25 here. No matter where you start, no matter where you start, you will end up, no matter where you start, you will end up going to, this state, steady state आपके पास आ जाएगी, and this is for very large values of n. This is P one n, and this is going to be P21 n, P21 n. इसी तरह P22 और P12 उसको भी ड्रॉ कर सकते हैं, वो 0.25 पे कन्वर्ज होंगे. Okay? So does not matter where you start, does not matter which distribution you start, you will converge to 75% of the time you will be spending in state one. Okay. All right. I have one more example, but I will skip that example and put it in the class notes that we will share later on. वो हम बाद में share करेंगे, तो वो example आपके पास आ जाएगी. So I'm going to now talk about some definitions. कुछ definitions हमने cover करनी है. Last time we said कि limiting distribution exist करेगी, limiting distribution exist करेगी and will converge to the stationary distribution if the Markov chain is regular. If the Markov chain is regular. Okay. If the Markov chain is regular, then limiting distribution will exist and will be equal to the stationary distribution. So इसके अंदर एक रेगुलर है, इसको एक्सप्लेन करना है. हमने कहा था कि इररेड्यूसिबल, अपीरियोडिक हो. So we need some definitions here. And I'm going to talk about those definitions. And next time we'll talk about the infinite state discrete time Markov chains. But before that, we need certain definition. So first definition is Pij n is the probability that in n steps you move from state I to state j. This is one definition. Pij, sorry, this is small p. Small p ij is the probability that in one step, also written as Pij 1, is the probability that in one step you move from state I to state j. State I से state j पे move करेंगे in just one step. So so few more definitions and the classification of the states. Few definitions and classifications of the states. first of all, accessibility. Accessibility. What do we mean by a state accessibility, or one state can access any other state? कोई इसके बारे में अगर guess करें, intuitively क्या लगता है कि ऐसे लगता है कि if you are in one state, you can go to if you can go to another state, रास्ता बंद नहीं हुआ हुआ, if you can go to another state, you will say that the state is accessible. The state is accessible. Okay. So formal definition is state J is accessible from state I if Pij n is greater than 0 for some n. If Pij n, so इसका मतलब है कि आप कुछ steps में, we are not saying कि 1 step or 2 step or 3 step, in some steps, ठीक है, for some n you can transition from state I to state j if the probability of that is greater than 0, then we say that I can access j. So every state is accessible from itself, even if there is no self loop. Every state is accessible from itself, even if there is no self loop. So what that means is Pii 0, this is equal to 1. This is because in zero steps you are at the same state. Okay. Now this is accessibility, and then we have communication. State I and J set to communicate are said to communicate if I is accessible from J and J is accessible from I. If I is accessible from J and J is accessible, J can access I can access J. Okay. Also written as bidirectional I J. I से J भी जा सकते हैं और J से I भी आ सकते हैं. ठीक है. If I can communicate with J and J can communicate with K, then I should be able to communicate with K. So I'm going to give you an example जहाँ पे स्टेट जो है वो एक दूसरे से कम्युनिकेट ना कर सकेंगे, accessible ना हो. ठीक है. And this is a Markov chain that I'm going to consider. This is state 1, state 2, state 3, and state 4, state 5, maybe, and state 6, state 7, 5, 6, and 7. Okay. So 1 and 2, they can communicate with each other. I'm not writing the probability transition matrix here. Probabilities we need draw kar rahe. So let's say you have this here, and then maybe let's say you have 3 and 4, and 4 goes back to 3, 4 can go to 6, and 6 can go to 5, and 3 can also go to 5, and 5 can go to 7, and 6 can 7 can go to 6. Now, if you think about it, कि कभी अगर आप state 3 में चले गए, is it possible to go back to state 1 or state 2? It's not possible. 3 से कभी आप, this is complete Markov chain. This is complete Markov chain. If you are stuck in 3 or 4 or 5 or 6 or 7, there is no way you can go back to 1 or 2. So 3 does not communicate with 2. 3 does not communicate with 1. 4 does not communicate with 1. In fact, 1 and 2 are not accessible from any of the other states. 1 and 2 are not accessible from any of the other states. So now answer yes or no. Is 7 accessible from 4? Yes or no? Is 7 accessible from 4? Yes or no? Answers in the chat window, please. Yes, 7 is accessible from 4. क्यों? क्योंकि हमारे पास ये एक पाथ बन रहा है. Sorry. 4 से 6, 6 से 5, and 5 से 7. So 7 is accessible from 4. Is 3 accessible from 7? 3 accessible from 7? Yes or no? 3 accessible from 7? Yes or no? 3 is not accessible from 7. क्योंकि 7 में आ गए, so you can go to 6 or 5 and then come back to 7. There is no way you can go back to 3 or 4 or 1 or 2. हम जा ही नहीं सकते हैं. So we got some idea about accessibility क्या होती है and communication क्या होती है. We know about accessibility and we know about states communicating with each other. Okay. Now, irreducible Markov chain. Irreducible Markov chain. A Markov chain is called irreducible if all states communicate with each other. If all states communicate with each other. Yeah. Now, I'm also going to define a transient state and a recurrent state. Transient and recurrent states. Transient and recurrent states. Transient state क्या होगी और recurrent state क्या होगी? So हम define करते हैं. FII is the probability that xn will be equal to I for some n greater than equal to 1 given x naught is equal to I. इसका क्या मतलब है? इसका मतलब है कि आप state I में अभी तो मौजूद हैं, but in future you will return to that. If the probability of that is non-zero, then we define that to be equal to FII. FII 0 भी हो सकता है, FII 1 भी हो सकता है, ठीक है? So state I is recurrent. इसका मतलब है बार बार आप वहां पे जाती हैं if FII is equal to 1. If there is 100% chance that sometimes in future you will come back to that state. Okay. How many visits to I? How many visits to a recurrent state? कितने visits होंगे? Infinite visits होंगे, क्योंकि अभी आप उस state के ऊपर हैं. In future you will come back to that state with probability 1. So once you come back to that state, then you will again come back to that state with probability 1. So that means you will make infinite visits to a recurrent states. Okay. The state is transient if FII is less than 1. If FII is less than 1, then the state is transient. Then the state is going to be transient state. Okay. Okay. So consider a Markov chain that V is the total number of visits to state I, then first, if the state is recurrent, then we will have infinite visits to that state. Okay. If I is recurrent, then V is infinite. V is infinite, which means the probability that V is equal to infinity given x naught is equal to I, is 1. The probability that V is equal to infinity, this probability is 1. B part, if I is a transient state, then you will not come back with 100% guarantee to that state. Yeah. You may come back with some probability Fii, which is less than 1, you may come back to that state. Yeah. So अब आपके पास Fii, which is let's say 0.8 probability hai, that you will come back to that state. Okay? So 0.8 you will come back, and then 0.8 you will come back, then 0.8 you will come back, then 0.8 you will come back. Okay, then but every time you come back here, there was a 20% chance that you will not come back. This looks like a geometric random variable to me. Okay, then V given x naught is equal to I. This guy, number of visits, is governed by the geometric random variable with 1 minus Fii, with parameter 1 minus Fii. So lastly, I am going to talk about what we call periodicity, period of a state. So period of a state J is the GCD, greatest common divider, is the GCD of the set of integers, n such that Pjj after n steps have elapsed is greater than 0. Okay. So if you come back to if there is a chance that you can come back to a state after 1, 2, 3, 4, 5 type of steps, then take all of those numbers and then take the GCD of those, and the GCD of those would be the period of the state, So we give you an example, 1 and 2. Okay. This state 1 will have a period of 2, because you are guaranteed that you will come back to 1 with a period of 2. 2 के अलावा और किसी तरह से नहीं वापस आ सकते. Okay. Similarly, 1, 2, 3. This guy, state 3 will have a period of 3. State 2 will also have a period of 3. Okay. All the states which communicate with each other, 1, 2, and 3 in this figure, they communicate with each other. All the states will have the same period. Okay. So a state is called aperiodic if its period is 1. So अगर self loop होगा उसके अंदर तो उसका period 1 हो सकता है. So that means कि if there is a self loop, then the state will be aperiodic. If all the states are aperiodic, then the Markov chain is aperiodic. If the Markov chain is aperiodic, then it will also be a regular Markov chain, given it is irreducible. और irreducible के लिए क्या था कि all the states communicate with each other. If all the states communicate with each other and one state is periodic, then all the states will be periodic. All the states will be aperiodic. Okay. So if all the states are aperiodic and the Markov chain is irreducible, then it will be a regular Markov chain. जो regular Markov chain होगी, उसकी stationary distribution तो exist करती है, उसकी limiting distribution भी exist करेगी, and the limiting distribution would be equal to the stationary distribution. Okay. So we'll have all of these, explained in the notes as well with some more examples. We'll upload the video as soon as it is available. If there are any questions before we close the session today, I will be happy to answer. Quick question? No questions. So I'm going to stop the share and we'll end the session.